Hi and welcome to my PlayHouse, and today I'm gonna go a bit further with these rendering servers up here, and I'm gonna test them or connect them to the render manager and try and send a job to them and see if they will join in and do some frames for me. I'm only working on the 9 machines over here and behind the screen, and there's like 2 virtual machines on each of them. Every virtual machine has about 4 or 8 gigabytes of RAM. It doesn't really matter, but they have 4 cores each. And yeah, let's go see that on the computer. While you're at it, give me a thumbs up, please. So I've climbed back home and I'm in my creepy basement, my man cave, and I'm doing some computer work, and I want to show you the render test on these 9 servers that I've been preparing, and I've been installing the Windows XP Pro 64 bits and installing 3D Studio Max. It's an older one, 2013, and I want to show you how that all comes together and how to use this in a render farm. I'm not going to go into detail on how it's all configured. I'm just going to show you how it works. Here we are on my computer in my basement, and I have connected to my render farm via remote desktop. And right here I have the desktop of one of my virtual machines that we're gonna be having a look at. And first, oh, there's an error. Don't do that. I have turned on these 9 servers, and each of them has 2 machines, Windows XP 64 bits servers running, or these are actually more like client OSs, but I used them as render servers. Let's have a look at something else. Oh no, let's go back and have a look at that. We have those 9 servers. I have this, which is a Windows 2003 server. It's right here, Windows Server 2003, and this is a 3D Studio Max Manager that I've installed on that, and that's why I call it Manager. Down here I have a Windows 7 machine, and I've called that 3D Studio Max. Let's go in and see those. There we are, and here is the Manager. And the Manager has this thing running over here, and that's the Manager, Backburner Manager, which is a part of 3D Studio Max. And right now there's a lot in it. I had to record this over because the recording quit on me. So I had this all started up and started, and then the recording stopped. But all the servers has checked into the Manager and says, I'm here, do you have any jobs for me? And that's the successful registration here. So we're gonna minimize the Manager, and we have something called the monitor as well, and down here we can see the servers from number 13 right there, from number 13 to number 30. So that's ready to go. Oh, we can keep that, and let's go in and render something. This is a Windows 7 machine. It looks a lot like the other machine, but it's a separate machine, and it has 3D Studio Max, the 2013 edition for 64 bits, and we're gonna boot that. It takes a little bit. It's not too much. Boom, boom. I could do some singing. Well, maybe not. And up here we can open the latest thing that was open, and blah blah blah. Yes. And we will get the Hummer now,
And this is the benchmark Hummer that I used in my other rendering video that I did last week. If you haven't seen that, I highly recommend watching that first. This is kind of the next video in a series on getting the most out of your render farm. I tried the Hummer on my normal office PC and it was rather slow, and then I tried it on a server and that was a bit big, a bit faster. And now we're gonna be using it on a render farm with 18 servers rendering this picture. So let's go into rendering and render setup. And in render setup, I want to do a couple of things. First, I want to render all 100 pictures. They are alike, but I want to show you that 100 pictures, how that is done. And I want to save those to file. And I'm so lucky that it has remembered the last place where I saved them. And I did some testing yesterday, so there is some Hummer files right here. I did a test of 10 pictures. Now we're gonna do a test of 100, so I'm just gonna steal the name again. And we're gonna export it as JPEG. You wouldn't normally do this, but well, I'm not gonna be using these pictures for anything. It's just for the testing, so it doesn't have to look good. And it takes exactly the same time if it's doing JPEG or TIFFs or anything like that. Save. And we can set some colors. We're not going to. Then there is one more thing that I want to set when you're when you're rendering with more than one core. You can set the size of a square that each core is rendering. And it has a little benefits when at the very end, if one core is doing a job that is very hard and it's doing a big case. I have 4 cores working on this, but if one core is later than the other 3 cores, then they will have to wait for a long time for that core to end. So it's often beneficial to make this bucket size. Bucket wide thing a little bit smaller than the 128 that it has to start with, especially if you have a lot of cores. So instead of doing the render, we are gonna hit the button right next to it and submit to network rendering. And here we get the network rendering. We're gonna call this project 02. And I'm gonna connect to this guy. That was my 3D manager, and that was the 2003 machine. So when I connect to this, I get all the servers over here from number 13 and up to number 30. I think we can make them turn around so that they're in a nice number way. And I am gonna turn on all the servers right there, use all servers, and I'm just gonna submit. And it's asking me if I'm sure that I wanna overwrite this file. I'm sure. It was just a test. And right now I am returning to my 3D Studio Max work. And if I was doing 3D Studio Max and not just testing, I would be able to work on and do the next project that would be ready for rendering later that day or something like that. So let's go and see what the other servers are doing now that we send a job to them. First, let's see the manager. What are you doing? It has received a Hummer 2 project. And if we go into job summary, there is some information about it. It has a priority, and it was submitted, and it was started to, what is that, 2 seconds or 2 milliseconds? I'm not sure. And it contains of 101 pictures, and that's about it. And task summary, let's minimize this a bit so we can see some more. Right there. And we can see that these are the individual frames. There was 101 frames, and they have been given to different servers over here. Like frame number 1 has been given to server number 13, and so on and so forth, until frame number 17, which is the last one that there was servers for, and number 18 is waiting for available servers. And if we go down here, we can see that all the servers are now busy. Okay, that's cool. Let's open and see what the servers are doing. And I have number 26 here, and it's rendering. You can see the hammer here is coming along, and these squares, I don't know if you can see them. They're not that well. Yeah, it consists of squares, and sometimes there is a new square that is done, and there should be 4 squares. Let's just see the processor. It's really being maxed out. It's at 100%. And as you can see, there is like 4 cores in this CPU, and each of these cores represent a square in the render. Oh, I have to turn this off. Here is a square right there, and there will be one next to it and one next to it and so forth. And so that is working good. And if we go back and see at the servers, they are here. That's a bad example, this one. And if we go in and see performance on the server, it's very busy right now. Advanced. Yeah, we can see the test that I did earlier, and right now it is peaking again. Like all the processors are maxing out, and it's very busy. In a little bit, the individual servers will starting to come up with alerts. VMware is alerting you, or alerting me, that the CPU usage will be way too much. So it will start to complain about that, probably within a couple of minutes. This render job takes about 9 minutes for each frame. So with 18 servers working on 101 frame, it should take about an hour or something, 60 minutes. So the first servers are starting to be done with their frames. And you can see, let's see, number 32 was just... The servers are all alike, so they are pretty similar in how long the frame took. And if we go up here, we can see that frame 0 was completed in 9 minutes 30 seconds, and they're all around those numbers. We can see that frame 4 was a bit slow, and I'm not worried about that, but if it was much more than that, I would probably go in and see what could be wrong with this server. Why is it slower than the other ones? Let's go and see what machine number 26 is doing. If it has started a new frame, and over here it says that it elapsed, it took 9 minutes and 10 seconds. It's not completely accurate. This is only the time that 3D Studio Max think that it took. The Q thing, I think that's more precise. Let's see if we can find number 26 up here somewhere. 26, where are you? There we are. It was actually a lot slower. Apparently, it's probably because I was teasing it. I was showing the CPU usage and stuff like that. So that stressed it a little bit more. We can see number 25. I think it lives together with 25. That's not it. There we are. 25 and 26 are on the same server. Here we can see the alert buttons coming on. And if we check those alerts, it's very busy. Yeah, it's complaining about the host CPU being too busy. And let's see, number 25 that it was together with is okay. So probably I was stressing this server too much. And then we have number 28 here. That's slow. And there might be a reason for that. 28 would probably be together with 27. And that's 11 minutes and 33 seconds. And why is that? Why is this slower? I think I have the explanation for that one. Let's go in and see. That would be down here. Yep. And there's a reason for that. The reason is that this server has a slower CPU. It only has a 2.5 GHz CPU, where all of the other servers has a... Come on, I'm waiting for you. Busy. They have a 3 GHz CPU, so this one is missing half a gigahertz, and that makes it a couple of minutes slower than the other ones. It's very clearly like it's actually exactly 2 minutes slower than all the other ones. Let's go down and see how far we are. We are working on the next row of frames. So the next we're working on the first 36 frames. The first 18 frames has been delivered, and the next 18 frames are on the way. And now the next row of frames are being completed, and as usual they're a bit faster than the first one. This time the program doesn't have to load and stuff like that, so often it's about 30 seconds that is cut off from the first to the second frame. So right, there are about 8 minutes, all of them, except the ones on the slower server. Now let's go in and visit number 26 and see how that is doing. Oh, it's just working on the last small squares. That's the last square, and it's gonna start the next frame. There we are. So that's why they're a bit faster. It doesn't have to do anything. It just have to reload the frame and start rendering it over. I'm curious on how long did number 26 take. It took normal time this time. Actually, it was pretty fast. So by not stressing it, it didn't take any longer than the other ones. We're probably waiting for number 27 and 28. They will be coming down here, taking the next couple of frames, but they won't be in for a couple of minutes. Well, as we can see here, number 27 and number 28 was also quicker on the second run. It's just up here they were on their first run, 11.5 minutes, and the second time they were just under 11 minutes. And we just saw a complete frame being done on server number 26. And right now they are working on the frames from number 17 till number 87, and that means that they'll be done in about 10 minutes, I guess. Hopefully just about 10 minutes. And let's see what the render farm says. All the servers are maxing out. This one is not so bad. Let's see what it says. We can see each frame being done. It does a frame and it drops, and it does another frame and it drops, and I don't know what those small things here are, and right now it's doing another frame. And the same thing on this one. It has the same drops. So this job is getting to the end now. As you can see down here, some of the servers are actually going into idle mode, which means there is no more frames for them. So the first 4 servers has gone into idle mode, and that's because there's only from number 87 to number 100. What is that? 13 frames left, and the last 13 frames will be dropping in. So there is 9 minutes, and then the job will be completed. Let's just see what number 26 is doing. They should all be doing the same. Oh, number 26 is apparently one of those who has dropped into idle mode, or it has failed. Let's see what is it doing out here. Yeah, it's gone into idle, so it's not doing anything. Let's find one of the servers that actually is doing something. Number 13 or number 21 is the last one. Let's see how far that is. 21 right there. Let's see what that is doing. And it's rendering happily also. Alright. Looks like it has just started, hasn't been running for long. So cool. I'm not gonna stress it, just gonna leave it. So this job just completed. I wanted to show you the last frame being done, and unfortunately it was number 20. Oh, it was number 27 and 28, wasn't it? Yeah, they were the last one to complete a frame, and they were the slow ones, so I was waiting for them for a while. Now we can go into the job summary, and we can see that it was started at 8:06:04. The job was submitted. It was ended 18:59. So it's almost 7 o'clock. So it took about 55 minutes to complete those 100 frames on 18 servers with 4 cores each. That's a total of 72 cores that has been working on this project, and it took just under 1 hour. And let's just say that I have a calculator here. Let's say that we were just using one server. it would of course have taken about 18 times as long, but let's do the math. 9 minutes times 101 frames divided by 60 minutes. It would have taken one server 15 hours and 15 minutes to complete this, and we did it in just under 1 hour. So that's the real benefits of having a render farm. You save some time. Now we have been rendering on these 9 servers. Let's just see them. Where are we? We are here. Here are the 9 servers that we have been rendering on. Oh, I can't. But that's not the entire render farm. I have my IP plane right here, and these are the servers that we have just been rendering on, those 9 servers. And down here I have the rest of my servers, and they're not even on there, all of them. I have a total of 248 cores available for rendering. I would get a lot of problems with heating if I turn on all of them at once, but it's possible. Other places, these are calculated in gigahertz. Like every core has some kind of gigahertz calculation, and I've done those calculations as well, and I have a total of 647.84 gigahertz something, and it's something that you do when you calculate how much rendering power you got. Just to show you that it's a fairly big render farm, and we were only playing with like 1/3 of it. So if everything is powered on, I could probably do this in 20 minutes. This is the monitor, and it says that the job has been completed. I think it gives us an average. There's an average right here. Each frame there's an average of 9 minutes and 9 seconds. And I'm probably gonna do another video where I show you how I am actually able to get that down a bit. This setup has not been fine-tuned. If I needed to do it a bit quicker, I can actually do that. There's a few small things that can be done that will actually make the servers render a bit faster. That was the rendering of 101 frames on 72 cores. So yeah, I shut down most of the servers again, and yeah, that's how you do 3D rendering in a render farm. And I'm gonna be showing you some more videos on how I optimize this, because it's not always. I already showed you that I use more than one virtual machine on each of them, and that has the benefits of actually giving better performance than just having one virtual machine with 8 cores. But yeah, I'll get into that in another video. Thank you for watching. Do subscribe to my channel so that you can see me again. Have a really nice day. Bye bye.